All right. First of all, Samuel, that was awesome. We're just gonna have a pandas day today. So yeah, I wanted to convert this first slide to just a GIF of pandas, but let's get in. So I'm going to talk to you about statistical typing and data testing. And these are two concepts that have been around, I think. But I think it sort of encapsulates what Pandera does and what its purpose is. So before getting into it, a little background about myself. I did a bachelor's in biology and dance and got into public health. So I did a MPH. And during that time, I got into statistics and data science and sort of now have fallen into machine learning engineering. So I'm there at Union AI right now, where we build machine learning orchestration tools. I'm also a FlightKit OSS maintainer. FlightKit is the Python SDK for that orchestration tool I mentioned. But today I'll talk to you about Pandera, of which I am the author and maintainer. I would say my sort of mission nowadays is to make DS and ML practitioners, data science and machine learning practitioners more productive. So the outline for this talk is, I'll first get into data testing, what it is. And actually, the author of PyJanitor, Eric Ma, has helped me kind of think about this a little bit more clearly. I'll do a little Pandera quick start, and then outline the guiding principles that have sort of led the library to where it is in its development today. I'll talk a little bit about scaling Pandera, in other words, scaling data validation. And then I'll finish off with a more theoretical take a little bit on statistical typing and what exactly that means. And then I'll wrap up with sort of future roadmap stuff. Okay, so this is a pared down definition, basically from one of Eric Ma's blog posts. Data testing is validating not only real data, but also the functions that produce them. And to show you what I mean, in the real world, you might have some raw data. You can't control what produces that. It's like the function of the universe generating this data. And you want to use it for some downstream purpose. Maybe you're analyzing it or training a model using that data. So invariably, you're going to have to clean it and transform it into a form that is, ready for analysis. And this is just a sketch of a pipeline. In the light green boxes, you see this raw schema and transform schema. And these are kind of intermediary steps that sandwich the transform function. And I'll show you in code how this kind of translates into Python in a little bit. But basically, we're defining these green artifacts here that are sort of checkpoints that say, okay, raw data coming into transform function, I want you to look a certain way, even if it's just the data types and the column names. And then on the other end, you have transform schema, which is what you expect transform function to do to the raw data that, you get the transform data out the other end. In a test suite, a data test for validating the functions that produce data is another matter. So here, what I'm showing you is, this will become a little clearer, but basically Pandera schemas are generative, just like Pydantic and a few other libraries that support synthesizing data as a function of the spec that you gave it, the class definition. You can do the same thing with Pandera. And Samuel referenced hypothesis, which is also another piece of functionality that Pandera integrates with. But in this case, we're using the raw schema to generate test cases, so kind of valid raw data. And we're passing it through transform function, and then we're checking the output of that. So you can think of this as a unit test, right? So each of those test cases is a unit test generated by hypothesis or whatever tool you're using. Traditionally, I guess you would, hard code, static data. But this is something that also encapsulates this, activity that I'm calling data testing. So my life before Pandera, I guess a little background. So, I was a data scientist before machine learning engineer. I'm not sure what the titles mean at this point, really, but whatever you're doing, you're going to have to clean data. That's just, there's no getting around that. So, you can imagine defining a clean function to process this raw data. And, you can plug in PyJanitor here. This would be a good place to use it to clean your data. And we're working with this, data cleaner.py file. Now, a test suite unit test for this clean function might look like this, right? I'm hand coding this mock raw data. I'm doing some checks that there's at least some null values, so it just kind of verifies that null values are allowed. You're checking the data types of each column. Sorry, just to go back here. I don't know if people had enough time to just look. So we just have two columns, a continuous and a categorical column. And you'll notice, like, I'm asserting that the continuous column is float, but if you look back here, it's not. So, the clean data function's job is to, change the types of this thing. And some other assertions, right? So this is a typical way of maybe writing a unit test. Maybe you break it out further. So now let's actually implement the clean function. Here, I'm just going to use vanilla pandas. So I'm converting the types here. I'm assigning certain values. So what I'm doing here is actually say I've decided the continuous column can only be positive and the only valid categories are A, B, C. And I just, we've decided, let's just null the invalid values. So if I run this test clean function back here, the test passed. So this is all also executed on Jupyter Notebook. So this, I'll note later, actually in a later slide, but all the code you see here is validated by Pandera. So this is a quick slide for Pandera. Basically, it's an expressive and lightweight statistical validation tool for data frames. And you can do a bunch of things with it. It's, at this point, fairly feature rich. So I recommend going to the docs. But the three core things you can do with this are you can check the types and properties of data frames. You can integrate it with your pipelines via decorators, and you can synthesize data from the schema objects you define. So Pandera comes in two flavors. So the first flavor is the object-based API. This is the original API for Pandera. And if you look at it, it looks very much like how you would define a data frame. It's like a dictionary, well, how you might define a data frame. It's a dictionary of column names and properties about that column. So just to linger on this a little bit, the continuous column is a float type that has to be greater or equal to 0, and it can also be nullable. Here, the categorical checks for string types and checks the valid set of categories for this column. And providing the coerce equals true here, which means that these first arguments per column will, instead of checking the type, it'll actually try to coerce whatever raw data is coming in into that type, and it'll raise an error. It'll blow up if it can't. The second flavor for Pandera is the class-based API. This was actually written by the co-maintainer of Pandera, Jeff Zank. So shout out to him for this API. And it's very, if you know Pydantic or data classes, like the syntax is quite similar. You inherit from some base class, and then you define class attributes as your fields, either columns or index. The type annotation is the type that you want the series for that column to be. And this field assignment will attach additional properties. So these are the built-in checks provided by Pandera. So the biggest pain that I came across and kind of the motivation for this is date times. Like date times would just always be incorrect whenever I would deal with them. And then obviously the other types, right? But I wanted to know which exact value, what exactly was the failure case? Like which index, which column did that failure case occur? And Pandera offers this nice interface for catching errors, right? So Pandera, when you call validate, it'll either return a valid data frame or error out. This is different from how other validation libraries do it, where you call validate and you get some data structure of errors. So here, this is very much tailored to the developer experience for a certain developer experience that you may or may not prefer. But here, if you look at these failure cases, it's very clear where things happened. As I said, the meta here is that this presentation, all of the code that you're seeing has been validated and run and checked by Pandera. Some guiding principles. So life after Pandera for me was a lot easier. There's some things. There's a little overhead here, which is you have to think about the data types. And I think it's well worth it. So it's kind of like a discipline and practice you sort of have to get into. But once you've defined your data types, right? I'm saying this is my raw data, and then this is my clean data, and the Python's inheritance semantics play in here. So clean data inherits from raw data, meaning that it gets all the columns from raw data. But now I'm attaching additional properties. So not only is continuous a float, it is also greater or equal to 0 and nullable. And this is how you start thinking about your functions and how the input and output types relate to each other. The first principle is parse then validate. And this is stolen from Pydantic, that distinction of parsing what you can and then validating certain other properties. So in this case, I have a function here, and let's break this down. The raw data input is of type raw data, and I can answer any questions about the exact syntax here of here's the Pandera generic type, and then I don't want to get into typing too much, but you can see clearly from this type annotation, the raw data you expect it to be of this type that we just defined back in the previous slide, and then it outputs clean data. And if I decorate my function with Pandera.checkTypes, it's going to check run validators against both the input and the output of this function. So now I can reduce my test to, right now I'm still making raw data. So we'll see later how we can skip this step also. I basically just invoke the clean function on the mock raw data. If any errors occur, then Pandera will complain, and this unit test basically becomes an execution test of the clean function. By the way, if you don't have to decorate it here. So if you just want this for type information, great. You can still wrap this function with check types in your unit test if you just want it for unit testing and you don't want to slow down your production pipeline. But in general, I feel like it's a good thing to just validate things in production. I don't know. I guess it depends on the trade-off of latency. And then here I'm asserting I have an invalid data frame here. It doesn't contain the continuous column, and I expect there to be a schema error here when I invoke clean on the invalid raw data. The second principle is to maximize reusability and adaptability. So once I've defined a schema, I can import it to other parts of my code base. It's just Python code. I can serialize it, and I'll show you different ways of doing that. You can do all sorts of stuff. And here you can use it in the source code and also in your unit tests, as I showed you before. So in this case, I'm not decorating this function, and I'm just applying the validator, the clean data schema, on the output of the clean function. Another kind of neat thing here, I didn't actually realize this when we were building this feature, is you can actually represent data frame joins. So I have my clean data, I have some supplementary data that I'm going to kind of join with the clean data, and to represent the join, it's just inheriting from both classes. So that's kind of a neat outcome that we didn't really think about when we designed this thing. And the last principle I'll talk about here is to bootstrap and interoperate. And so by bootstrap, I mean, like in the beginning, I mentioned it takes some discipline to write these schemas, but Pandera has a little bit of utility function in first schema. So it'll take in some presumably clean data, and then it'll create a schema for you, which you can then write out to a YAML file. So this is the YAML serialization format for Pandera. You can read that YAML file back in to memory somewhere. And you can also write it to a Python script. So if you invoke schema.to script, it'll spit out a string that you can write to a file. And this will be this is like a fully specified schema with all the default arguments. So you can mess around with it, delete stuff if you want. You can also port schemas from a frictionless table schema, which is another kind of project that I've been keeping tabs on, and someone made a contribution to import from a frictionless schema to a Pandera schema. Oh, that wasn't the last principle. So basically, I'm also interested in facilitating property-based testing with generative schemas. And this is not the best example, because each time I run this notebook, it samples a different set of examples. But if I take my raw data schema and call the .example method, I can specify what size data frame I want to generate from that schema. You can see here that clean data strictly adheres to membership of the set ABC, and these are all positive floats. So this is going back to that slide. Let me see if I can hop back real quick. Yeah, so this thing, right? So I said raw schema generates test cases, which I pass to test my function. So that is here. Oop. And I won't go into it too much, but here's our clean function, and I'm using hypothesis here. There's a decorator that say at given some strategy for generating these samples is passed into the test, the unit test, and you can use that then. So now like the unit test just looks like this. I'm just invoking my function, and like literally hypothesis is doing all this work of generating test cases. This is nice too, because I can define an invalid data schema and just make sure my clean function is not able to process it and raises an error. Cool. So before getting into statistical typing, which is kind of like the last topic here, there has been, there was sort of demand for scaling this up to larger data sets. So we did some work and integrated with dask modin. Koalas is kind of temporary because PySpark data frame or pandas is now a thing. But say we have this raw data, I can say imagine it's much bigger. I can use the exact same schema definition to validate the dask data frame. And the code is, it's like, for modin, it's like you're reusing all of these schemas across these different libraries. Cool. So finally, statistical typing is something I Googled around, and I think there's like academic work on this, but it's called something else, and I haven't been able to find it. But it's typing with a statistics flavor, and I'll get again into like what that exactly means. But first, I guess I want to motivate type systems, right? Because maybe not everyone is a fan of MyPy or those kinds of projects, but I would argue that they help programmers reason about and write more robust code. So if I have this simple function, add and double, takes two numbers and outputs another number, I can sort of, even without the correct implementation, I can already statically look at these invocations and tell you, which ones are the incorrect, like will lead to an error, which is this one, right? And similarly, this is the pandas equivalent of that. So you have your inputs, which are X and Y series. And then your output is Z, which is like the adding the two numbers and doubling the result. And here I'm showing off a little bit of Pandera's custom check definition API. So you can define methods as custom checks by decorating it as a data frame check in this case. So this has access to the entire data frame, and I can make assertions about the values of the data within the function body. So I would define statistical typing as extending primitive data types with additional semantics about the properties held by a collection of data points. And it looks like there's some typos in here. But so if you consider a single data point, right, what can you say about it? You can say what the types are of each column or field, what the field names are that are present, value ranges, maybe allowable values. You can do some regex string matching, check nullability. But if you have a collection of data points, you can, first of all, apply atomic checks at scale. So, if you use Pandas vectorized implementations that's kind of built into its methods, you can speed up whatever atomic check you're going to do per record and scale that up. You can check for uniqueness in a column, which you can't. That is by definition a property of a collection. You can check for monotonicity, your standard descriptive statistics, and like things like fractional checks, like 90% of the data points are null, for example. So this is maybe going into branding territory, but I kind of frame Pandera as a statistical type system geared towards data science and machine learning. And it provides this API for defining data frame types and enables a more intuitive way of doing this data testing thing that I was talking about. And so the last example I'll show you is hypothesis testing with Pandera. And here I'll use the OG flavor of Pandera, the object-based one, just because hypothesis testing is not very mature in the class-based API. So imagine I have this data of height and feet and some arbitrary groups A and B. You can think of them maybe as like sports, sports players. And you're saying, I want to say the height of group A is greater than that of group B, like in a kind of central tendency way. So this is, what hypothesis testing is good for. You can do some kind of sample t-test. You say A is greater than B on average. The column you want to use to get those samples are the group column, significance level of 5%. Assume the variance of the two samples are equal. And yeah, Pandera supports this type of API. It's not, I haven't gotten a lot of feature requests about it, but based on, I have a sense that building more built-in statistical checks like this would be useful to people. But please, yeah, do let me know if you do have this use case, because you could customize, you can build custom hypotheses. So there are just a few things in the recipe to do this. So you need a testing function that just uses SciPy in the back, and then some kind of evaluation function that's like, is this the result you were looking for? Can you reject the null hypothesis or something like that? And falsify your hypotheses today. Like the way, so if I switch the groups together, if I switch group A and B, this is Pandera saying, hey, actually B's height is greater than A. So the three things that we're focusing on this year is extensibility. So getting support for other complex data containers, which is we're like slowly expanding the scope and carefully expanding the scope. So trying to get support for X-array and JSON schema. And then an extension API, so other folks can come in and add their own validation engines. We also want to get better on the user experience. So error reporting is a little bit not ideal right now. More built-in checks and statistical hypothesis checks, different types of validation. And then finally, interoperability. So we do have integrations with Fast API, Pydantic, working on something for PyTest, but we'll continue working on making those integrations more useful. These slides will be available. I'll actually link them after I stop talking. These are some other resources you can use to learn more about Pandera. And yeah, consider joining the community, checking it out at least, seeing whether you want to define types for your data frames.
All right. Thank you so much. Yeah, any questions?
I'm intrigued. Let's go over the use cases again. So you say that it's good to run tests on data, but and I understood that you can repair data. So what other use cases you can find? Like I saw the statistical part at the end. It's kind of like a little bit blurred to me. What other use cases? Give me examples where I can actually use it a little bit more, so it will be clearer.
So, sorry, let me take a drink. So you're asking about like real world use cases that I know of?
Yeah.
Users.
Give examples of what people are using it for, so it'll be clear.
Yeah.
Because it's data is convoluted sometimes.
Yeah, so I know of, there's an abstract that came out last year, and it was the Children's Hospital of, I forget where now, but their data team was using it to validate survey data responses. So they have some survey intakes, clinical survey intake, and they're starting to use Pandera schemas to validate the data coming in. So I assume they're using pandas for their cleaning. There's an agency in the Singaporean government that's using it. I'm not sure exactly what their use case is, but they help to modernize small to medium business websites. So I'm guessing there's some kind of transaction data. I mean, I don't know. But I mean, like the fundamental use case is still, if you care about, forget about the statistical stuff, right? Like if you care about making sure the types of the columns that you're processing at sort of the entry point. So because there is a cost to this, right? Because running the validation checks might be costly. It's still up to the developer to figure out where those checkpoints are. But the clearest checkpoints are, raw data coming in from the real world, messy, and then you want to kind of checkpoint. You at least get a sense of, that the columns and the types are of the correct, of the expected properties. And then at the other end is when you do some processing and you write to a database. Before you write to a database, you probably want to check some of these properties as well. Mm-hmm. So it's not like a industry kind of vertical level use case, but generally as a data person, if you care about the types of the data passing at critical points in your pipeline, you generally want to define these schemas.
Yeah. I'm thinking about it, basically. I knew about Pandera, but didn't know about the statistical typing part. But this is awesome, by the way, Niels. Thank you. And
thank you.
I'm thinking about it like, say I'm pulling data from some API, and I have some known distribution. And I can use this next time I pull the API and see if the distribution holds, right?
That's right. Yeah. Yep.
Can I do like normality checks?
Yeah, that's one that is not built in, but if you're familiar with SciPy, you can like look at the the documentation here for how to define custom types. Okay. And again, it's all functions
right.
of a particular signature. Yep.
Cool.
I see a question in the chat. Do Pandera and Pydantic pursue similar goals? If not, what are the differences? Yeah, I think Pydantic is great for like Python objects and like heavily nested, like very, nested types, where you can have, dicts of lists of dicts and all that stuff. And when you have a complex, say, configuration file or a complex record, Pydantic would probably be the tool for that. There is, where we are working on more interoperability. So you can check out the documentation here for integrations. So Pydantic, you can use Pandera schema models in your Pydantic model. And very soon you'll be able to specify a Pydantic model as a data type of your schema. And it'll just treat it as a row-wise validator. So it'll just, you sacrifice a little bit of efficiency there because you're not using the pandas operations for like, checking if something's within some range. But that's the user's choice.
I have one question. Niels, do you have any experience, like ballpark estimate, in terms of how long does it take for a group of engineers to adapt Pandera?
To get your first schema and start validating stuff in like a production pipeline, it depends on the complexity of the data set.
Yeah.
But mechanically, it's defining that object and like annotating the data frame type. And then putting your, at check types decorator.
Right.
So it's just designed to be super lightweight and incremental. You don't have to buy into a lot of stuff. The main thing you want to buy into is I want to check types.
Right.
Yeah.
Nice. Thank you.
I see a comment about infer schema. Yeah, I've chatted with the author of Pandas profiling, and we're gonna do something where you can take a Pandas profiling report and turn that into a Pandera schema. So going back to that guiding principle.
So Niels, thank you so much for the talk. I was hoping I could ask you sort of more of a higher level question about something you had brought up about halfway through. So
Sure, yeah.
you had made this comment around it can be a little bit of a change in your workflow to think about explicitly validating data types at each step along the way. So, you might be someone who's used to just data from somewhere, you chuck in pandas, you use transforms and you write it out without really thinking too hard about what the types are. Would you be able to talk to us a little bit about like what that journey is like, that sort of change in perspective?
Yeah, it's like 9-hour long running training jobs, and then you're like trying to write out your history somewhere and something, craps out. So like the mindset comes from, for me personally, from just getting burned. Like the day-to-day adoption of it is, it's still, I'm very much like a fan of the gradual typing approach that Python is taking. Like when I'm starting my analysis, I just want to get to some result quickly. And then when I get some result, I would always like bother my coworkers being like, if your Jupyter notebook isn't validated, then like the conclusions you're making, are less, I'm less confident about them. So once you get to that endpoint, you kind of double check your work. And as part of that double checking process, you're like, oh, something happened here. Let this seems to be kind of an important place for things to be correct. So after a long chain of transformations, you'll do, just one checkpoint there. And I find that that's enough. So, if I'm doing a query, SQL query or something, and I'm like pulling something from a remote location, I'll cache it for analysis, and I check that too. So make sure that's what I expect it to be. And then sort of it's cool too, like validating data that you're about to visualize, because you can see exactly, you see the visualization and you're seeing like the properties of those dots that you're seeing on your scatter plot or something. So usually it's at those spots where you take some time to do it. Like production, like scheduled by production, that means a lot of things, but say you have a cron job that's running every hour or something, it's probably worth, slapping some schemas at the tail end, the head and tail of those pipelines too.
Awesome. It's really helpful. Thank you for sharing. I'm also a fan of the gradual typing approach.
Oh, all right. Any more
Awesome.
questions?
Can you say a
Thanks,
little
everyone.
bit more? Can you say a little bit more of the gradual typing?
Oh yeah, I mean, in a nutshell, it's like you don't have to adopt typing. So there's the design of Python's typing system is such that, if you're using a type linter like MyPy, it's not going to check functions that aren't annotated. But once you add that annotation, it'll start, type checking the arguments and the outputs and, the functions that are being called within it, given that they are also typed. So it's just this idea that, and I think it's, strategically it makes sense to start introducing types and not breaking everyone's code base, or like, if not breaking, then like if it was like a feature flag, like turn all types on now, like it would just be unworkable to start adopting it. So I think, I'm not sure if there's any more to that, philosophy. Maybe there probably is, but that's my understanding of it.
Okay, thank you. That's nice buzzword.
Yep, yep.
Actually, to you and Samuel both, how are you balancing your time from real work and then to open source projects like this?
Samuel, you want to take that first?
Samuel muted, I guess.
Oh.
You start answering.
Let Niels go first. He has more experience.
Now we can hear.
Okay.
Okay, here we go.
All right. Okay. Yeah, it's a good question because it's something that the general cadence I have now is I'll work toward a release after I get contributors in and whatever they're working on and shepherding their things through. CI is always a pain.
Mm-hmm.
I'll kind of take a break for a week or two. I'll answer like questions here and there, but I won't do any serious work on it for 2 weeks. Yeah. And generally, that helps me kind of get the motivation back.
Mm-hmm.
And it's 2 hours here and there, 3 hours here and there on after work, after hours on the weekends.
And some companies are kind enough to sponsor, like say your open source contributions too. Yeah.
Yep. So there are mechanisms out there, but that is also work.
Yeah.
Yeah.
For me, I enjoy the open source programming. It is by far and large the best way I have become more proficient at coding. Open source and Stack Overflow. I know we like to give Stack Overflow a lot of hits, but I don't know how the world will run without Stack Overflow. Going to Stack Overflow and answering questions. I mean, there was a period I was answering questions every day, and it has really helped me get better. You see, you answer the questions, you look at other people's answers, you see better answers. It compels you to study the documentation more, understand what you're doing. Why is this faster? Why is this better? Why is this cleaner? Yeah, open source is fun for me. I take time. I enjoy my job as well. So on weekends, I just go and play football. I play soccer. Soccer is a very intense game. If you're into it, you hit each other. You have the banter the same way we have the banter. I just had the banter with David. Sometimes it gets right down to actual insults, like insults, what you can use on live, on air. But at the end of the game, you guys relax. You have a beer if you need to have a beer. You talk. It's good. In that period, I forget about the worries of the world. I forget that I have 2 kids. I forget that I made a mistake in one of my coding, whatever. Life is easy. I move on. And then the moment I get back home, the computer starts calling me, hey, remember this code, it's over here, try and fix it. But yeah, that's the way I take my breaks. And then, of course, since I have 2 kids, they're a handful. There's always something, somebody writing something on the wall, or somebody saying something they shouldn't be saying, or me having to explain to my daughter something that I feel like she's too young to understand. Yeah, at that point, coding is nothing.
Awesome, thank you. Thank you.
Soccer is God's game.
Just
put things in perspective.
We should probably stop the recording now.
Yeah.
We'll talk about it right after.
Unless anyone has any important question before.
Yes, let's do it. Yes. Any more questions for Niels?
So I think we have one more question, Anton. And this is to both of you. Anton is asking if you have tags specific to PyGender and Pandera on Stack Overflow. And if you have like notifications set up, you can answer those questions quickly.
For PyGenitor, no, we don't have tags. I don't know, we never discussed about it. I don't think it's necessary for us to have a tag. Paginator is subservient to pandas. So if it can help us with the pandas questions, fine. If there's a better way to answer it, fine. Again, it's just a helper, nothing more than that.
Yeah, I think there is a tag for Pandera, and I do get email notifications on there. So I've stopped saying author here, exclamation mark, the beginning of my responses now. But yeah, I am on there, but generally the issues and discussions on GitHub are where I look at the places I look at most often.
Awesome, thank you.
All right.
Thank you.
If there are no more questions, then let's thank Niels for showing us how Pandera works. And again, thanks so much for coming by. I appreciate it.
Thank you.